Hi folks, welcome to this second video in what I'm calling a crash course in counting. In the first video we looked at fundamental counting principle. In this video we're going to look at something called factorial notation. In the video description below you'll find a PDF of the notes, both blank and filled in. And in the notes there are also some practice questions. Often we're interested in how many ways we can arrange a set of objects in a row, or arrange them, whether we're talking about a playlist or a lineup of people. So let's suppose Alice and Bob are getting in line at a store. How many different ways could they get in line? Well, that's really easy to do just by writing out the possibilities. It could be Alice then Bob, or it could be Bob then Alice. Those are the only ways that we could have this lineup happen. But another way to think about this is that there are really two choices for the first person. It could be either Alice or Bob. And then the choice for the second person actually just goes down to one, because whoever's first is not going to be the second one. We don't have to know who's in the first position to know that there is only one possibility here. And straight out of fundamental counting principle, that tells us that there are two ways to arrange two people in a lineup. That's no big surprise. Now let's suppose that Catherine joins Alice and Bob in the line. So we could have the line ABC, we could have the line ACB, we could have BAC, we could have BCA, we could have CAB. Oh my gosh, this is taking a lot of time. So 6 possibilities. It's not too onerous yet. But really, the number of choices you have for the first person is 3 choices. And whoever you chose for the first person isn't going to be the second person. So you have 2 choices for the second person. And whoever's the third person isn't either of those, so you're down to just 1 choice. So there's another way to figure out that there are only 6 people in this line. This is really still just fundamental counting principle. Okay, now let's suppose Dan and Emily join Alice, Bob, and Catherine. I mean, you can pause the video and find out all the different ways that you'd arrange 5 people in a line, but the first choice could be A or B or C or D or E. Okay, so 5 times 4 times 3 times 2 times 1. Okay, let's see what that is. 5 times 4 is 20, times 3 is 60, times 2 is 120. That's a lot faster than having to write them all out. So there are a lot of ways. In all of these cases, we're just multiplying down. So we're going 5 times 4 times 3 times 2 times 1 all the way to the bottom. If we want to find the number of ways to do it for 10 people, I mean, we could write all this out. But it turns out that there's an expression of writing it that looks like 10. But we actually say 10 factorial. And 10 factorial means 10 multiplied all the way down. Let's check it out in the calculator. So in gory detail, writing it out, 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, we get 3.6 million-ish. How I can get my calculator to do that faster is to press 10 factorial. And it'll be in different places in different calculators. It looks like an exclamation button. If you have a non-graphing calculator, chances are it's second function of something. I have to press math, and I go over to PRB for probability. And it's down there, so it looks like this. But you'll see it will return the exact same value. It's a more elegant way of saying 10 multiplied all the way down. So factorial notation means 1 factorial is just 1. 2 factorial is 2 times 1, 3 factorial is 3 times 2 times 1, and so on. One thing to note here is that 0 factorial is defined as 1. And you can go into great depth of looking at like the gamma function to figure this out. But that's probably beyond the scope of what we're looking at right now. So we can take it just as fact. But if you're really interested in diving just a touch deeper on this, Eddie Wu has a fantastic video on this that I'll link in the video description below. It's fairly short. So your calculator can figure out factorials. In how many ways could you arrange 12 different books on a bookshelf? Well, you could say, I could have 12 choices for the first one, and then 11 choices for the second one, and 10 all the way down to the very last one, and then times 2 times 1 for the 11th book and the 12th book. But an easier way to write this would be, instead of just multiplying these all together, use this slick notation, which is 12 factorial. I can actually do this on Desmos. Hit 12 factorial, it tells me 479,001,600. Stuff grows fast with factorials. How many arrangements could there be of all the letters in the word Kilby? So 1, 2, 3, 4, 5 letters. So you'd have 5 choices. And notice they're all different letters. So they're distinguishable from each other. So you could say there's 5 choices for your first letter and 4 choices for your second letter because you've used one up, and 3 choices for your second. If you're wondering, how many different anagrams you can make here, this is kind of useful. But we can also write this just as 5 factorial, which we've already established is 120. There's some practice questions on this stuff, so I'll just scroll through them slowly. But again, the PDF is down below, and there are answers on the very last page. You can see there where it says factorial questions. If you want to hang around to go through a few of them, here's one. How many ways can 8 people be arranged in a line? So that's going to be 8 times 7 all the way down. It'll just be 8 factorial, whatever that works out to be. And we get 40,320. I like this one in 3. The musical scale is 12 notes. How many different arrangements could be made with all 12 notes? This is actually the subject of a famous book written by a Russian mathematician named Nicholas Slonimsky that formed the basis of a lot of the practicing that John Coltrane did. This idea of 12-note sort of arrangements also has to do with 12-tone composition in the early 20th century, but I like the Coltrane reference better. And it's basically just 12 factorial, and we've actually already done this question, just in a different context in the examples. There we had 12 factorial for example 2. I'll go through 9 and 10 as well. The volleyball team has 12 members, 2 coaches, and a manager. So that's 15 people. If you put them all in one line, it'll be 15 factorial. And we can work that out as a number. Suppose the team above takes their picture with the starting lineup of 5 people and the coaches in the front row. So essentially you have a front row, and the number of ways that you can set it up is 7 factorial. And then you have a back row, and the number of ways you can set it up is the other 8 people, 8 factorial. The neat thing here is that the fundamental counting principle still applies. You can do the front row, so the number of ways you can select the front row is 7 factorial, that's a lot. And then select the back row, you just multiply these together. So the fundamental counting principle is very, very powerful. It can be used as sort of an extra layer in some of these questions. The numerical answers for both of these can be found in the answer section of this handout. I hope this has been helpful, folks. Good luck with the material, and take care.